rate of change. And it is a ratio. That just means a fraction that compares how much one quantity changes on average relative to the change in another quantity. Now, x is always going to be your independent variable. Underline that part. What do you think of when you think of the word independent?
By itself.
By itself? I'm not talking about math. Besides the song. By itself, what else? When a person's independent, what do you think?
They don't rely on anything. They do them.
Good. They don't rely on anything else. What else, Darren?
They do them. They do what they want to.
They do them. Okay.
Yeah.
So anytime that we're looking at data like this to find rate of change, when it says time and temperature, which one sounds independent? Time. Good, because time doesn't depend on anything else, right? Nothing change. Time just never changes. It never stops for anybody. So time will always be our independent variable. And so time will always be which one? X or Y? Good. So for these data that we're doing, these charts, go ahead and put an X beside the time. Time will always be independent. It'll always be our X value. So all the other ones are going to be our Y's. Our Y values. Now the formula for rate of change, which you kind of need to know for your test, but it's common sense, is changing X over changing Y over changing X. What operation do you think of when you think of change? Anybody? Subtraction. Like if I were to take Kelsey's height right now and her height when she was 3 years old, the change in it would be what? I would have to do what? Subtract them. So change is talking about subtraction. Whoever's phone that is, if you'll just turn it on silent. Thank you. Alright, and then also sometimes you'll see it as delta y over delta x. So that triangle right there, in case you didn't know, means delta. And that just means the same thing here, changing y over changing x. Alright, so I want Ransom for you to pick 2 y values, just any y values from this table.
143.6.
Yep.
131.4.
I don't know why I keep putting my decimals. So those are the 2 y values he picked. Again, it does not matter, or maybe it does, we'll see, what y value you pick, as long as on the bottom our x values go underneath the y value it corresponds with. So what is the x value here?
0.
And here?
2.
Good. So go ahead and subtract the top, and somebody tell me what that is. I don't have a calculator, so I'm going to trust you. What did y'all get on top? 4.2. Does everybody agree? And on bottom you'd get, and now I want you to divide that. And tell me what you get. Good. And with rate of change, I want you to put your measurements, units of measure. So what was our y value? What measure is that? Celsius. Good. So Celsius per what? Minute. Good. And what does this negative indicate? That what? Yeah, the temperature is dropping as time is increasing. Good. Now, do you think it would matter if we picked different y values?
No.
You don't think so?
Yes.
I'm just asking.
No.
It would matter? Okay, so Antonio, give me 2 different y values. Y'all don't have to write this part down.
118.4 and
126.8. So tell me the x values that have to go underneath that.
128.
Alright, what's 12 minus 8 on bottom? And on top, what would we get? Subtract those for me. Somebody. Negative 8.4. Now divide it. Tell me what we get. So does it matter?
No.
No. But this, when it has the same and it doesn't matter what y values you pick, what does that tell us about the data? No. What does that tell us about the data when we can pick any y values and get the same rate of change? It's constant. Good. So that means the function is probably what if we were to graph this?
Linear.
Linear. Thank you. A straight line. Okay. Let's do the next one. So Darian, give me two y values.
12, no. Yeah, 12 and 24.
Alright, so 12 minus 24. Tell me what goes beneath them.
2
2,
and 4.
not and 4, minus 4. Tell me what 12 minus 24 is, anybody? Negative 12 on bottom. So our rate of change is 6 what? Feet per. Good. Any questions? Try the last one on your own. Number 3. And those are not decimals, those are commas. People are confused about that. I want you, if it's a decimal, I want you to round to the nearest, let's do hundredths. 100. Here's 100. Make sure you put your units and measure, so for this one you can just go. Make sure you put your units and measure. Alright, now compare your answers to people around you. Ask them what they got. Finish it. Finish it first. All you do is pick 2 while the change is right. So pick 2 of them and write them down. Minus. Nothing about it. Roll a bar.
I don't know what you do.
Now what's the x value here? Minus. Now find it. Alright, what did y'all find out? Did y'all have the same answer?
Yes.
Are you sure? Because I saw some people with different ones.
The people I asked, they had the same thing as you.
I saw 362. I saw some other ones. Do anybody have anything different? Focus on you. So everybody have this? Okay, moving on. So if the graph of a function is not a straight line, there is no rate of change. The average rate of change. And from now on, we're going to use AROC. So when I say AROC, that means average rate of change. Between 2 points is the slope of the secant line. Does everybody know what a secant line is? Straight line that goes through how many points? 2. Let me write that out here. Secant line is a line that goes through 2 points. Yes. So if you did not know that. A line that goes through 2 points on a graph. So you can see here that the secant line, see how it's going through 2 points? This point and this point. We're going to find the average rate of change between those 2 points. So when he was 13, I don't know what the boy's name is. We'll just name him Miles. So we're going to find Miles' average height from when he was 13 to 18. Okay? So notice that our x value, or our x-axis, is talking about age. So that's going to be our x. And our height is going to be our y, because that's on our y-axis. So average rate of change is the change in what over the change in what? What goes on top? Good. Change in y over change in x. So what was his height at age 13? 57. And what was his height at 18? 76 on your graph. All you got to do is look at it. Alright, and so we said that at age 13 it was 57 and at age 18 it was 76. Go ahead and find his average rate of change on your own. So what'd y'all get? Which is what as a decimal? 3.8 inches per year. Good, which means that Miles, between the ages of 13 and 18, was growing 3.8 inches a year between those years. Okay? Alright, flip that over. Now we're going to be doing the same thing except with a function. Okay, so same formula, change in y over change in x. Just now we're going to be working with functions. So here's our function for number 1. And they give us our two x values. Our x values are 0 and 1. How do we find our y values? Y'all know this. Alright, Katie, how would I find my y value at x equals 0?
Wait, what?
I have an x equals 0. We're trying to find our y value. What do I do with this? Good. Plug it in for x squared. So 0 squared would be what? 0. So that's my y what? 1 that I just found. Good. Same thing, I'm going to plug this into this function. So 1 squared would be what? 1, and that's my y what? Now we're going to find the average rate of change. A-rock. So what goes on top? What do we subtract on top? Our y's. Do y'all want to do 0 minus 1 or 1 minus 0? 1 minus 0? It doesn't. And so what's the x value for 1? 1, right? What's the x value for 0? So on top we would get on bottom. So our average rate of change? Very good. All of these different ones, this is the function you'll use for b as well, x squared. So go ahead and do b on your own. And again, this is the function we're using. For x, so it's negative 2 squared. What's negative 2 squared? And negative 2 times a negative 2. Good. So you would write y1 equals 4. So what's y2 going to be when I plug this in? Good. Now set up your equation. So on top you can put either one of these first. So which one will I do? 4 minus 0. What's the x value here? X equals what for this one? And what's x equal for this one? So. Alright, Colby, what'd you get? Huh? Alright, let's do it together then. Alright, tell me what this would look like if I plug this into this equation. Yes, because negative 2 squared is 4. And we just found our what right here? y1. Where do I get what from? This is the function you plug it into. So you're just replacing x with negative 2. Alright, on this one, Colby, 0 squared is going to give us what? And that's our what? Good. So on top, we're subtracting our y's. Tell me which one you want to put first. So 0 minus what? Minus what now? Yep, over. Good. So on top we would have, and on bottom, so our average rate of change. Good. Raise your hand if you got that on your own. Okay. Let's do the next one together. This time it's the same thing except cubed. X cubed. So when I plug 0 in, I'll get what for y1? 0. And for x2? What now?
Wait. Decrease.
What? What'd you say?
You said you plug in cube.
I'm plugging 1 in for x cubed. That's going to give me what? Thank you. Alright. Sorry, that's y2. Alright, Kaya, tell me which y you want to put first. So 1 minus over. Good. 1 minus what? Which makes? Which is? Good. Alright, do the next one on your own. So this is still the function we're using for part B. Alright, everybody say what they got out loud. 3. Very good. I need to go over this one?
Yeah.
Okay, Amber, what'd you get for your Y1? Alright, how'd you get that? Good. So negative 2 cubed is going to give us negative 8. Very good. And then what'd you get for your Y2, Amber?
1.
Good, because 1 cubed is 1. Alright, and then tell me how you set it up.
I did 1 plus 8 with the negative and
Good.
minus. 1 plus c on the bottom.
And so that gave you what on top?
9.
And on bottom?
3.
Good. Alright, questions about that? Yes. Where did I get 1 plus 2? She did 1 minus negative 2 on bottom because we're finding the change. But when you write 1 minus negative 2, what happens to those? Okay. Alright, so same thing. Now we have a word problem where we're finding the average rate of change. Just underline this part. That's the only important part. Between 3 and 7 hours. So the 3 and 7 are our x's or y's. X's because they're what? Hours is talking about time, right? So those will go on bottom. And what order do y'all want to put them in? 7 minus 3 or 3 minus 7? Okay. So we just need the drug concentration in the blood, milligrams, at 7 hours. So what would that be at 7 hours? 0.02 minus what? Good, 0.5. Go ahead and find it on your own. Make sure you put units of measure. All right, Miles, what'd you get?
0, -0, 1, 0, 0, 7, 5.
7.5. Good, milliliters per hour. Very good. Did everybody get this? Yes. All right, see where the part where it says homework down at the bottom of your paper? You can mark that out because you have your study guide that I want you to work on. So I don't think it's fair to give you homework and study guide when it's all due on Friday and you only have 2 days. But get out one blank sheet of paper because you're about to have a checkpoint. So on your sheet of paper, I want you to put your name, date, and the class period. One blank sheet of paper. There's paper up there if you don't have any.
Is this on separate today? Friday too.
This is the notes we just finished. So yeah, it's a little bit of Friday. So put name, date, and class period on one blank sheet of paper. And you can use your notes. Yes, you can use your notes. So how about your 2.4 notes? This is all from 2.4. Alright, just a reminder that a checkpoint is a quiz grade. So if you're caught talking to anybody during this, you'll get a 0. Because it's individual, I want you doing it on your own. Whenever you get done, just raise your hand and I'll come help you. Or excuse me, I'll come check it. And if it's correct, you can either pack up, but I would rather you work on your study guide. Okay? If you don't finish this before Friday, you can't take your test. You have to finish this. You have to make a 100 before you take your test Friday. Does everybody understand? Okay. The problem, you don't actually have to copy down the problem. It'll be up under here. I just want you to work it out on your paper. Okay? And I'll put the problem up here. And it's going to go away for just a second, but I'll bring it back.